Oh hey, I didn't see you there. My name is Professor Caleb, and today we're going to learn about chemistry, specifically acids and bases. Alright, so the first thing that we're going to learn about today is the Arrhenius concept. And this theory was made by a man named Svante Arrhenius. And it states that acids produce hydrogen ions in aqueous solutions and bases produce hydroxide ions.
An Arrhenius acid is a substance that increases the concentration of hydrogen ions when added to water. An example of this may be HCl. Also Arrhenius bases, which is a substance that increases the concentration of OH ions present when added to water. An example of this is NaOH, aka sodium hydroxide.
Right, up next we're going to learn about the Bronsted-Lowry model. This theory was made by a man named Thomas Lowry, and it states that the general reaction that occurs when an acid is dissolved in water is the acid donating a proton to a water molecule to form a new acid and a new base. Wow, that's a lot of information. So let's compress that into human words. Basically, it means an acid is a hydrogen donor and a base is a hydrogen ion acceptor.
A conjugate acid is the particle formed whenever a base gains an H+ ion. A conjugate base is the particle that remains whenever the acid donates an H+ ion.
The last thing we're going to learn about today is acid strength, and as you can tell, it talks about the strength of an acid. It's measured on a scale called the pH scale, and it goes from 0 to 14, 7 being the neutral. A pH scale, like this one for example, can help us tell whether a substance is an acid or a base. If the number is below 7, it's an acid. If it's above 7, it's a base. If it's on 7 directly, it means it's neutral. For example, it would be like water or something like that. So we're going to do a little experiment to test this. With me I have here ammonia, water, and vinegar. So we're going to put some pH paper in each and test to see if that works to show us. This is the pH paper thingy. As you can see, the scale is on there. If it's red, it means it's an acid. If it's blue, it means it's a base. So here we go. So as you can see, it turned red. So that would be an acid. Let's do water. Look, neutral. Just got a little wet. Nothing different about that. So that would be a neutral one. And wow, look at that. Nice and blue. That means it's a base. Dissociation is whenever a strong acid or base ionizes completely in water. So a strong acid is one that completely dissociates, and a weak acid is one that partially dissociates. Acids and electrolytes are actually related. A strong acid equals a strong electrolyte. A strong acid completely dissociates, causing the ions to complete the circuit, making a strong electrolyte. This has been Professor Caleb. I hope you learned a lot about acids and bases. See you on the flip side.